So official welcome to today's SAP community call on the topic of native machine learning and SAP HANA Cloud. My name is Lena Stodal. I am part of the SAP Community and Influencers team and your technical host for this session today. I'm joined by my colleague Christoph Morgan, who is Senior Product Management Lead for the SAP HANA Machine Learning. I'm happy that he joined us and that he will give us an insight on native machine learning in SAP HANA Cloud. So that is why you guys are all here. Our SAP community call, as you might all know, is 60 minutes. Christoph is going to present to you for 45 minutes. As I mentioned, he will give you an overview of the latest and most recent enhancements in SAP HANA Cloud Machine Learning and how SAP basically has been applied this for our customer implementations and how it is applied by our SAP stakeholders. In case you have questions, you know, at the bottom of the screen, there is the Q&A button where we would love you guys to ask your questions because we have 15 minutes towards the end of the call to address those. Christoph also mentioned if there's urgent questions that you would like to address to him directly, during the presentation, you can do so. Just raise your hand and I will be able to unmute you and you can address your questions directly. This is really your chance because we have the expert here with us today. And with that being said, I'm handing over to you, Christoph. The stage is yours.
Thank you very much, Lena. And yeah, welcome everybody also from my side to this overview and intro session about our native machine learning capabilities in SAP HANA Cloud. So please take notice of the disclaimer, just in case we are also discussing forward-looking topics, or I might be wrong on some of the topics I'll be presenting. The agenda today is an overview and a demo about our native machine learning capabilities in SAP HANA Cloud. I want to give you some examples of what customers are doing using our HANA native machine learning capabilities and how SAP applications are adopting those. And yeah, briefly overview some recent enhancement of the latest HANA Cloud QRC release, and also give you an idea about the roadmap where we are heading to, and then we are already in the Q&A. So if you're building an SAP application or seek to enhance an SAP application or build your own, you may want to embed AI capabilities as kind of providing intelligence to the intelligent enterprise theme of your company or your customer's application. So by using AI, you're really driving the intelligence in our business processes and application by adding notifications, AI-driven explanations, predictions, recommendations, forecasts and planning, simulations, etc. All these typical scenarios kind of add intelligence to classic, let's say, more or less manual applications and business processes. And therefore, out of SAP Business Technology Platform, we provide a variety of AI functions and capabilities as part of the AI business services, data intelligence, also conversational AI or intelligent robotic process automation, but also SAP HANA Cloud provides a unique set of embedded AI functions or machine learning capabilities. And if your or the application in focus is already running on SAP HANA Cloud, then basically you can leverage the intelligence out of the box. The native machine learning capabilities in SAP HANA Cloud are the first choice of, let's say, AI function library. And yeah, so SAP HANA Cloud is ready to kind of infuse your application with AI. We provide automated functions as well as expert function and algorithm for adding that intelligence into your application. Beyond the machine learning topic, the AI topic we are focusing on, certainly there's document store, spatial graph processing, search and text processing capabilities, which add to the let's say, multi-model enrichment of an application. And also we're providing beyond the SQL interface, certainly therefore a database. There's also native interfaces for data scientists in R and Python we will overview. And on top of that, as everything is running in HANA Cloud, you certainly get the cloud advantages on top, like the real-time federation capabilities in HANA Cloud, the embedded data lake, and also all the scalability and elasticity options of HANA Cloud. So if you augment your application with machine learning, then basically all the development scenarios certainly also support this in the business technology platform as well. What are classic machine learning scenarios we have in mind or focus on when we talk about machine learning or AI scenarios with SAP HANA or SAP HANA Cloud? The classic ones are classification. So if, for example, you'd like to predict customer behavior, like is a customer likely to churn to fraud or likely to buy a certain new product? Therefore, you classify the customers with respect to that objective scenario you have in mind. So that's the classification scenario. For regression, we do a kind of a similar thing, but we're not predicting, let's say, a categorical value or behavior, but we'd like to predict a continuous value, like a car price. We'd like to predict a car price or a sales figure in this example given here based on the car model characteristics or given market trends. The third most common scenario is time series analysis and forecasting, likely similar to regression, but the data we're actually looking at is time related. So we use a sequence of historic time related data to predict not only a singular value, but a series of future sales, demand, cost, whatever value. That's when we speak of forecasting. And then all the other scenarios we also see quite often, but less frequent, like clustering. We'd like in marketing scenarios, like to take our overall customer group and segment it into subgroups. Therefore, we can use clustering techniques, or in predictive maintenance, maybe outlier detection in our sensor data is also a common scenario we see often with our SAP HANA customers. So if we now look at the AI function libraries, the first library, if you are not an expert already, you would like to should look at is the Automated Predictive Library. It is really good to start with because it automates the complete analysis step from data preparation, meaning feature or variable selection, variable transformation, to the actual model training, selecting the algorithms, the parameters for the algorithm. So you're very fast, if you're a non-data scientist, to come up with a good first model to do your prediction in the areas as we touched upon, like classification, regression, time series forecasting, and some of the other areas as well, which are supported by the Automated Predictive Library. So simple functions for developers, SQL developers do great train, apply, deploy, and query predictive models. And it's very popular also for expert data scientists in, for example, POCs, as it provides a very fast time to value by applying these predictive functions. So simple to consume and easy to apply. A good first choice if you are new to applying predictive models for classification, regression, or time series forecasting. However, in some scenarios, you'd like to really get to the edge to basically build the best possible predictive model. And for those scenarios, you then would touch upon the expert machining library, being the Predictive Analysis Library, or short PAL, in SAP HANA or SAP HANA Cloud. PAL embeds trending algorithms like gradient boosting, random decision trees, or profit in the area of time series analysis, which we implement there as expert functions required and demanded by our customer, but also as demanded by our internal stakeholders. So we are continuously enriching the library with new functions. It's designed, the algorithm implementation are designed to run as fast as possible in HANA as the in-memory processing engine with specific focus on real-time inference, so apply of predictive models as fast as possible within, for example, S4 HANA transaction. But we also support massive parallel scenarios like segmented massive forecasting, which we often see where we'd like to, or use cases like to build not only a single forecast model, but a forecast model by each location of a store, for example, and execute that in real time in parallel, and therefore the segmented scenarios are also really popular. Explainability has become a very crucial ingredient of the overall scenario of applying AI and machine learning, as customers and business users like to understand why a predictive model or AI model came up with a given prediction. So providing insights into individual, let's say, predicted values or forecasted value has become a crucial capability. Typical SAP apps applying our AI functions is integrated business planning or S4 HANA. We'll talk about those later on with some more detail. The advantages of Predictive Analysis Library in HANA Cloud, we'll see that we provide innovations and new functions with every quarter. And again, on top, you can leverage all the advantages HANA Cloud brings by itself, like the federation capabilities, the scalability capabilities, or you can store your data or your models, whatever, also in the HANA Cloud data lake as well. The scenarios are similar to the scenarios which can be addressed with the Automated Predictive Library. As you can see here, classification, regression, time series forecasting, etc. The ones which I explained earlier as the classic machine learning scenario. So we're not looking with HANA Cloud to provide a platform for image classification or object detection in videos, etc. So we're not in that, let's say, deep machine learning or deep AI scenarios, but more in the classic machine learning scenarios on structured tabular data. Now that's the typical scenarios we seek to address as part of our business application, intelligent business application with our native HANA machine learning capabilities. So just to give you an idea, if you are new to the Predictive Analysis Library, so it's a library with more than 100 algorithms implemented in those areas: classification, regression, time series analysis, so forecasting, cluster analysis, etc. And yeah, now the crucial difference between the Predictive Analysis Library and the Automated Predictive Library is if you want to apply high function, you need to be an expert to decide, which classification algorithms do I apply for my problem. So that's something which is not automated for you at this stage. That's something you as an expert need to decide, because you know that multi-class logistic regression, for example, provides better insight in a given scenario of your data compared to classic random decision trees, for example. But as I said, we have trending algorithms like random forest or random decision trees, hybrid gradient boosting, or the additive model analysis, as we call it, which is our profit implementation in the area of time series forecasting. Yeah, but this was only meant to give you an idea which algorithms are there. In blue, we kind of highlighted the recent enhancements in SAP HANA Cloud as well as SPO6, and the green highlighted algorithms are currently only available in SAP HANA Cloud. And we'll see the green ones will be growing again over each quarterly release of SAP HANA Cloud and the PAL library. So how can you now make use of the algorithms? Basically, there's a simple SQL interface with all the PAL algorithms having a procedure in the sysafl schema, as you can see here by the example. And you simply pass in your data to be analyzed, then a parameter table with the parameters to instruct the algorithm invocation, and then you can go off and get the results in an ad hoc fashion. For real and application integration and development, depending on what the application layer of the application is, you can make use of Business Application Studio and HDI design time database procedures, table functions, etc. To embed the SQL or SQL script call. If you run an ABAP based application, certainly ABAP managed database procedures is the implementation language of choice, which is used in the BW applications, for example, as well as S/4HANA, of course. Or if you are more in the native BTP application, then also Fiori CAP-based application development scenario supports HANA native objects, where you can, for example, use table functions or call database procedures as well. However, for our data scientists, SQL is nice, but we experienced we need to provide our native machine learning assets in the, let's say, expert workbenches of data scientist experts who can then take that decision, which classification, which regression algorithms do I need to use and do I need to apply best for this problem. Therefore, we provide, let's say, machine learning client libraries, meaning wrapper method in Python or R for the experts, which basically are used as a remote call to the actual algorithms then in the HANA database. And we'll see that live in a second. This machine learning clients in Python then also add spatial and graph capabilities as well, especially for importing graph data and spatial data or creating a graph workspace. And again, with this Python R machine learning clients, it's very easy to connect against the HANA Cloud instance. You can always then leverage the latest innovations from HANA Cloud and algorithm. And we've also seen customers using HANA Cloud to provide and provision sandboxes for data scientists as well. So there's a good match for the scenario by provisioning HANA Cloud instances for data scientists. And here's a first example, which we'll see in a second. Basically, this showcases how a data scientist would work and interact with a specific algorithm. Here's the classification algorithm from Python and the data and the algorithms in HANA Cloud. So all the execution happens in HANA Cloud and is instructed from Python as a language or R as a language. And I like to showcase and explain this now directly from a Python notebook. So that I'm switching screens here. So I'm in a Python Jupyter notebook, and what we typically do there first is we import packages. HTTP CLI is the Python database client, and HANA-ML is the machine learning client packages. So basically, I'm importing those, and as you can see here, I'm leveraging version 2.11, which is the latest release of the Python machine learning client, which was released just 3 weeks ago, end of December. Then I'm connecting against the HANA Cloud instance. Here prompted for my password. So I can basically specify here the cloud instance name, and then run against port 443. And with that, I'm connected against the HANA Cloud system. So you can see here, I'm connected against the HANA Cloud instance of just last year's QSC4 release. One of the capabilities here is that I'm creating a so-called data frame. Data frame is simply a virtual data object on the Python side, which simply holds a SQL query. And then SQL query could also be a multi-line SQL object, which is kind of what I demoed here. But typically, we create such data frames connecting against a table in some schema. And the data frame itself is simply a SQL statement. So I'm not transferring any data, and I can go ahead and manipulate this data frame or print again the select statement. I'm moving ID as the first column, so I'm changing the select clause basically, casting some values, etc. So all kinds of methods are available to manipulate this data frame, which is only the manipulation of the actual SQL statement. I can also run methods against this data frame now, counting the columns or counting the rows, and again, showing the columns of the data frame. And then there's a method collect. And if I run this method collect against the data frame, then I'm actually transferring data. As I'm using head first, I'm using the top clause on the database system, only transferring top 6 records over to the Python side, as we want to push all the processing certainly against the database. And one of the, let's say, nice methods here is the describe method, which gives me a univariate overview across all the columns of my data frames, like mean, standard deviation, min, max, etc., and all the percentiles. And if I show you the SQL statement behind that, that would be pretty lengthy and rich, and is all comprised in the single describe method here, which is really helpful for you to explore the data you're about to analyze. In our scenario, what we basically like to do is predict or build a classification model to predict if someone is likely to get diabetes or not. So class is our target variable here, 1 indicating diabetes, 0 indicating no diabetes. And the distribution here is 500 to 268. We can then also use some of the visualizations here, like correlating all the variables to see if there's interdependencies and intercorrelations. So all kinds of, let's say, exploratory methods here in the Python machine learning client. Typically, what we do is we split our data between train, test, and validation. There's also a method to do that. And as I've now created 3 data frames here, I can again run the count against them and see how the data has been split up. And now we come to the actual, let's say, machine learning. We want to build a classification model using our unified classification PAL function. There's a SQL variant of it certainly available. And we're using, let's say, some advanced approach, which are now really short, crossing over. So we're using grid search as we are iterating multiple variables, variants of the algorithm invocation. The algorithm is our hybrid gradient boosting tree classifier. And this is already finished, as it's a really small data set for the purpose of this demo. And as we can see here, we now get a result. So we get, for this model which was created, what are the important, let's say, features and their relative importance as part of the model. Just to continue that, typically want to validate then a model using a score function. And so you can see then here we get different model quality statistics on the test data, where we have the actual values and compare them against the predicted values, of course, and based on that we get the respective quality measures here for the generated model, and can then again create different visualizations, for example, with respect to the confusion metrics, or kind of run a prediction here with the predict methods, where we get the explainability, add on the recent code, which tells us, just executing the next one here as well, indicating what are the top contributing features for a given decision. As we talked about explainability here for record ID number 3, the predicted value was 0, and which values of the current record were actually contributing to this decision. For example, body mass index for ID number 3 was contributing about 48% the body mass index to this decision. So that's
Christoph,
or explainability values.
Sorry, Christoph, there's a question in between that I think makes most sense to ask now.
Yep.
Because later on it will be difficult because now you're in the demo. In line 52, Sam Marth asked the question, why exactly we're using .collect brackets function at the end. Is it to collect those info into notebook or something else?
Yes, exactly. So I wanted to kind of get the predicted results, which are in a temporary table on the HANA Cloud instance side, and I wanted to report them basically here over on the Python side. So
thank you.
Just for the visualization of the result, I'm using the collect statement here. And yeah, finally, just, I mean, I could go on and show you all kinds of capabilities here. But the last one would be the Shapley report, providing the global explainability, some more insights compared to the variable importance about value, also distribution, etc., which is also very, very popular. The last thing I want to show you, how do I now bridge this between the Python side and the SQL side. There's actually just new methods provided to kind of show the SQL, which is actually executed behind the scenes when the model was trained. And I'm simply copying this code and oops, now need to step over here into my SQL console in HANA Cloud, and I'm just exchanging the dataset reference. And because I have a different session here, certainly, that's why I can't use the temporary table used by the Python session. But if I'm now passing in that reference, I can actually run the code and train the new model. And basically you also use the Python machine learning client here. If I want as a SQL code generator, or the data scientist could generate a code and manually hand this over to the integration architect. There's also automated approaches to help doing that, but that would be, let's say, the manual approach, and showcase you how both are interconnected. On Python, I'm simply generating SQL and running that in the end behind the scenes in an ad hoc fashion on the HANA Cloud instance. As you can see here, there's the unified classification procedure called here. With that, I'd like to continue with the presentation. So the unique benefits of our SAP HANA Machine Learning capabilities, as I showcased, hopefully, we provide state-of-the-art algorithms out of the expert function library, and also the automated functions, which I couldn't show due to time. we have these trending algorithm implementations, and for the key scenarios, the classification, regression, forecasting, clustering. So please take that away. If you seek to tackle one of these scenarios, take a close look at what we provide as native machine learning functions. All the algorithms execute co-located with your data, and therefore can be part of any of the HANA in-memory processing capabilities of your overall application. Especially if you seek to implement these highly parallel segmented scenario where you don't want to move a lot of data out of the HANA database to some kind of other machine learning environment that's really best suited to be processed, co-located with your data in the HANA database. Certainly, it's a simple architecture, no extra service required. That's all out of the box given and can be even combined with other capabilities like spatial graph, etc. The data scientists are fully equipped with their expert languages. Database developers certainly would leverage SQL, and then depending on your application, there's also the application language interfaces available as well. So some customer examples. Ottogi is a Korean food consumer product manufacturer and was participating in our SAP HANA Cloud early adoption program. And their challenge was to implement a market share forecasting scenario, or to implement a more automated and more accurate forecasting scenario. And for that, they needed to integrate external data as well as point of sales data in a more real-time fashion, therefore used HANA Cloud and the data federation and integration capabilities to have this real-time, up-to-date forecasting data set. And then they used hybrid gradient boosting regression algorithm to implement a multi-step forecast across a granular segmentation of the respective product groups and also market groups and regional scenarios. So hybrid gradient boosting as the algorithm for this forecasting scenario, along with HANA Cloud as the real-time integration and federation capabilities. I think it's a really nice example, and you can take a look at the news stories here linked. Another customer here is Paul Hartmann, medical supply manufacturer in Germany, and that implementation started at the beginning of the pandemic here in Germany, where there was real and urgent need to provide a more real-time and transparent insight into demand and supply, and also to provide the respective medical assets to the regions in Germany where there is the most urgent need. And therefore, again, they integrated external data, like, for example, intensive care unit data, as well as other external data resources, infection rates, etc., on the local level, and then used segmented, unified, exponential smoothing algorithm to predict the respective demand for the next 5 to 10 days on the product level here. And for that, the data scientists implementing the project actually then also were dependent or leveraging the Python machine learning client, which really helped to accelerate the implementation success of the scenario. The same was true for Motor Oil Hellas, where 3 or 4 data scientists from an external implementation partner actually took the same approach, using Python as their expert homegrown environment against HANA Cloud, which again provided the platform for real-time integration of all the sensor data, as the target here was to ensure that the distillery operation of this oil refinery, the production line was not impacted by any unforeseen maintenance tasks or predictive maintenance was the scenario here. And HANA Cloud really helped with the aspect of that real-time data integration, as well as one of the trending algorithms, the profit algorithm here really helped, and its speed, which was available in HANA Cloud, to calculate a 36-hour look-ahead forecast for each of the sensor values of that production line, and therefore enable the customer to implement a more proactive schedule maintenance schedule for the respective equipment. So also a really nice customer success story. SAP applications providing access to our native machine learning capabilities. Certainly SAP Data Warehouse Cloud at the forefront as it's running on SAP HANA Cloud. The full suite of machine learning functions is available, like the Automated Predictive Library, the Predictive Analysis Library. So both native libraries are available. You can make use of them in the open SQL schemas, implement the scenario, provide the results via views, etc., back to the actual DWC schema. And also what we've seen is very interesting, that with DWC, it's very easy to provide, let's say, sandbox spaces to data scientists to actually experiment or build the respective scenarios. There's a couple of links here on the slide, which give you examples of how that has been taken to life with respective DWC showcases and scenarios. SAP Integrated Business Planning is one of the most crucial stakeholders for the PAL library in different modules like Integrated Business Planning for Demand, or also Sales and Operations Planning. Demand is completely depending on the Predictive Analysis Library as the algorithm foundation for the functions in the demand planning module, like time series analysis, classification, statistical forecasting. So if you actually, or your customer is running IBP demand, the demand module, they are fully using the PAL library. And at this stage, I think overall we have over 1,000 customers using SAP ABP, and therefore leveraging the assets of our native machine learning functions. S/4HANA, as our flagship, certainly has been implementing a series of machine learning scenarios in the area of, let's say, towards intelligent enterprise. And many, or more than half of the scenarios are actually leveraging the embedded machine learning capabilities, again, of the PAL and also the Automated Predictive Library. The implementation is based on ABAP managed database procedures, and there's also a management module for those scenarios called Intelligent Scenario Lifecycle Management. There's over 25 scenarios implemented in the different modules here, like public services, asset and service management, finance, inventory management, sales, quality management, supply chain, utilities. You as a partner or customer can certainly also implement your own scenario using Intelligent Scenario Lifecycle Management. There's a series of links again down here, and ABAP MDP examples, which you can have a look at and see how such an enrichment with your own scenario could easily be implemented. One of the examples here with a link to a YouTube video, the damage code proposal, where there's actually a PAL random forest classifier used to help with the UI, where for a maintenance job, someone would need to specify the object part, and in this case, the object part code is proposed by using a machine learning model. One of the scenarios we see more and more adoption of our embedded machine learning capabilities. Now let's have a look in what are the recent enhancements for the Automated Predictive Library. This is just a quick summary here. In different HANA Cloud releases, there's different versions of the APL library available. The latest is APL 21.23, which kind of gives you here some indication what's new in that version. Like, for example, the create model and train function here now includes model and debriefing in a single call, new indicator statistics and statistics tables are available, or new model reports are available, providing you with more insight on actually already trained models. As I explained, that the PAL library in each HANA Cloud release adds a set of new functions. I'm not going to the details here, just to give you the idea what's happening in HANA Cloud. With every release of the Predictive Analysis Library, you can see that there's a good set of new functions. And this is what we've seen highlighted earlier on the other overview slide on all the algorithms in the PAL library. In the last quarterly update of HANA Cloud PAL library, it's one new algorithm which was provided called isolation forest. It's a new algorithm in the area of outlier detection, leveraging a multidimensional approach, where basically an outlier is detected, because if you think of a decision tree approach in that multidimensional data space, to detect an outlier, typically the decision tree path for outliers would be shorter, as you can see here on the right-hand side, compared to values which really lie in the center of the data, where the decision tree path to such a value in that multidimensional space would be much deeper. So a trending algorithm again in that area, it's newly implemented and here provided with SAP HANA Cloud, also requested by customers, for example. Then for the unified classification and regression, we now support predict with state for faster inference with large models. They are then kept as pre-parsed, and single transactions can then apply those models in milliseconds. Our text processing and text mining functions in HANA Cloud introduced in the 21 Q1 release now also support German as an additional language. And our hybrid gradient boosting tree classification regression algorithm now provides new objective functions, which help you to come up with even better models, as you can then explicitly select the internal optimization objective function to come up with that model for different scenarios. So this is very maybe advanced, but for the expert data scientists among the audience, that might be really interesting. Again, here there's a link to all the new algorithms in the respective release. There's some, let's say, minor updates, which I'm not covering here due to the time constraint. And then as well on the level of the Python machine learning client 2.11, the release I've also used in the demo. There's again a rich set of enhancements. Certainly all the new functions have been adopted, like feature selection functions, BSDS, etc. Unified exponential smoothing in massive mode, etc. So there's always a function update for the algorithms as well as data frame capabilities, and certainly also on the area of visualization and model storage. There are some enhancements like the word cloud visualization for our text mining functions. The data frame support parameterized views, as the example shows here. on the screen. And then another function you've been using was the procedure generation methods, where I generated the fit procedure, copy pasted that into the database explorer, which really showed the value of using both alongside Python as the expert environment for the data scientist. Then you can generate a SQL and basically apply that to your development artifacts. Yes, and with that, please, as there's always enhancements ahead for our HANA Cloud machine learning assets, please always take a look at our roadmap in the Roadmap Explorer. Upcoming innovation is that we will provide pipelining and automation capabilities for our PAL algorithms in the area of classification and regression, and further out in time series forecasting. So a step into automated capabilities for the Predictive Analysis Library. With that, I then like to summarize. HANA Cloud, I hope you could see that, is ready to enrich your application with embedded AI capabilities. If it's an BTP application running on HANA Cloud, everything is available out of the box, different flavors of algorithm. You are on the fast track for getting all the updates with HANA Cloud, as well as enhancements to the interfaces for the expert data scientists in R and Python as well. And certainly you can leverage the scaling and elasticity capabilities and all the other advantages of HANA Cloud machine learning out of the box. And with that, let's go into the Q&A.
Thank you, Christoph. Yeah, we have 4 questions currently in the Q&A from Ashish and Thomas. One of which is, from Ashish, if my data is in data lake, then I will have to summarize that data in HANA or use SDA, but will that work for petabyte scale? That was regarding slide 13.
Yeah, certainly, typically you're not applying, let's say, one algorithm against a petascale data set, but rather out of the petabyte scale data in the data lake, maybe select a subset as you're filtering out data or aggregating data, and then leverage that and execute the algorithm against it. So that's the scenario we typically see. It's not one big data set of petabyte scale, which you'd like to apply machine learning on, but rather a subset.
All right, perfect. And then Thomas asked, he is interested about 2 things. So first of all, is there also an R package available to R to HANA integration? I know about the HANA to R integration, just want to know if it's now available the other way around.
Yes, so there's also the R machine learning client for SAP HANA. It's not as rich as the it's not as rich as the Python machine learning client is, but it's similarly available. And there's also blogs out there showcasing how you can, for example, create a Shiny app using HANA ML, the R package, and build a nice application where all the processing is pushed down to HANA.
I think you guys know each other because he just posted a question saying, by the way, hi, Christoph. Okay, so that is, and the other question was kind of the same thing, but for Python. I guess you kind of also already answered it. So is there a HANA to Python integration in case you are running a big Python instance?
Yeah, we basically have the Python machine learning client, but we don't have a Python runtime embedded in HANA where you can deploy any arbitrary, let's say, Python model. For that, there would be data intelligence or possibly our AI business services environment where you could possibly embed your custom model for a given business scenario, for example, as part of an SAP application. We have been investigating down that road with a customer engagement initiative, looking at topic called ONNX and then ONNX runtime, but that's still under research and planning. ONNX is a model conversion format for Python models, which you could leverage to convert the Python model to that ONNX and then do the apply of such a model in SAP HANA Cloud. So, but that's part of the customer engagement initiative and still under, let's say, investigation.
Thank you. Thomas, I guess if you have further questions directly, you can reach out to Christoph. It seems like that you guys know each other. And I also already shared his SAP community profile in the chat. One more question, Christoph, to you from Venkat. Can we try PAL, P-A-L, using HANA Cloud on BTP trial landscape?
That's a very good question. At this point, this is not available, but we are working on it. The challenge here is that the trial landscape are, let's say, of very small size, and machine learning scenario could actually leverage more than the resources provided for such a HANA Cloud instance. And our objective here is to provide you a stable HANA Cloud environment. Therefore, we are working on that, and hopefully we can provide PAL and the machine learning capabilities during the course of this year as part of the BTP free tier landscape, but that's still under planning.
Okay, more to come in that area. Thank you all for your questions so far. We have 5 minutes left. You still have the chance to ask Christoph your questions. What I really, really love at the end of such an SAP community call is to ask you, like the speaker, Christoph in this case, what are the 5 key takeaways for the audience that you would like to kind of wrap up the call?
Yeah, so the key takeaways are that, you should be aware that SAP HANA Cloud provides automated and expert machine learning functions for the classic machine learning scenarios like classification, regression, forecasting. So that's really a crucial takeaway. If you seek to tackle one of these scenarios, I'm sure you find the algorithms in our function library within HANA Cloud. There's no need for an additional setup of a machine learning environment. Second is, maybe you are not experienced as being a developer, SAP developer yourself. You can do multiple things. The first thing would be you start with the Automated Predictive Library, which takes all the burden and constraints of not being an expert. You can tackle the problem with the Automated Predictive Library. But the second thing you could do is involve an expert, data scientist from your organization, provide them with the Python machine learning client library, HANA ML, and then you basically connect the two worlds, the expert workbench with the HANA Cloud environment and the algorithms, and then it's very easy for a data scientist, for example, working in Python with scikit-learn to pivot to the HANA ML package and implement a given scenario on HANA Cloud, and you get the best of both worlds, the expertise from the expert, as well as the HANA Cloud as the target environment where you seek to implement the application in the first place. So I think that's the crucial thing to take away. Thanks for that summary towards the end here. As you all know, and there has been the question in the Q&A, this is a recorded session, and we will share the recording and the replay plus the slide deck on our SAP community homepage and on YouTube at the SAP community account. When there's no further questions. There's 2 more slides maybe I'd like to quickly show. So there's some reference information to the most important resources on HANA Cloud and HANA Cloud machine learning. Maybe the first one I'd like to show is here the HANA ML. Let's see, open up quickly. HANA ML in Python here. simply via pip install, you can install this module in your Python environment, or the data scientist can do. And secondly, if you seek for samples, we also have a sample repository. Oops. Maybe that's opened here. That's not over here. Come on. Give me a second. So under sub-samples, GitHub HANA ML samples, you find examples of Python code, R code, PAL SQL, APL SQL examples, which help you to get started and get the idea about how to leverage our machine learning capabilities. Certainly post your questions in the SAP HANA community, add the respective tags for machine learning in HANA Cloud, and then we likely to find them and be able to respond to your question. Yeah. And
one more question that just came in, Christoph. Yeah. Is it possible to install R and Python in our personal PC?
Yes, certainly. Basically, install your Python environment like Anaconda, and then you pip install the HANA package in addition to that. And the same for R. If you install RStudio, the R client comes with the install of the HANA client, and then you basically can install the added package for HANA ML.
And 1 minute left, just in time. Flavio asked, with all these functions, what's the benefit of SAP Data Intelligence regarding ML?
Well, the degrees of freedom in data intelligence are larger to what we provide in HANA Cloud with our machine learning capabilities. In data intelligence, you can basically execute any arbitrary Python code. For example, data intelligence also provides some, let's say, machine learning scenario management capabilities, etc. And also often we see that there's specific needs regarding the operationalization of the data flow, the overall data flow. And that would be certainly capabilities which are easy to implement using data intelligence. But I think there's two flavors of projects. The simple one is where you don't need data intelligence as an extra environment, where HANA Cloud with its federation capabilities provides all what you need. But if you need to go beyond, then maybe data intelligence or data warehouse cloud can help there for a given scenario.
Thank you so much, Christoph. Just in time, we're at the top of the hour. Thank you everyone for joining our SAP community call today. I hope I see you soon. Stay healthy, take care, and have a good one.
Thank you very much. Bye-bye.
Bye.